Hello, everyone. My name is Panos Vassiliadis, and I am with the University of Ioannina. And in this paper, I report on joint work with my colleague Apostolos Zarras and my former students Fation, Shehaj, and George Kalampokis in the area of schema evolution. So schema evolution is pretty much a dreaded phenomenon. It refers to the case where the structure of the database is changed, either because tables are added, tables are deleted, attributes are added, deleted, updated. And we have had anecdotal evidence so far that both developers and DBAs will do anything to avoid experiencing. In the last few years, we have also seen publications actually reporting on people's experiences with that. And why does this happen? It's the impact that schema evolution has. So you change the structure of the database. The surrounding source code either crashes because the queries are syntactically invalid, or they are semantically invalid because they miss some information, or the system goes offline in order to be able to synchronize schema and source code before bringing it back to full operation. So the impact is of schema evolution, it cannot be underestimated. For the last decade, we have been researching the area of schema evolution, trying to find the laws and patterns. And we still don't know too much about how schemata evolve, let alone how much a schema co-evolves with the source code. We work with large-scale studies via automated tool, and in this particular paper, we try to address the following three research issues. One, does schema co-evolve with the source code, and to what extent do they evolve hand in hand? Two, if schema evolution premature, which means does the schema evolution complete early enough in the project lifetime and then the schema remains fixed, whereas the rest of the code gets developed? And three, when does the schema obtain a significant part of its form? How early does this happen in the lifetime of a project? Before we answer the questions, we need to discuss a little bit the research setup because it's important. We work with a large collection of schema histories from the free open source domain. So we mined GitHub. We obtained 195 histories with a very principled collection protocol. This is reported in ICDE 21, and we are using this data set of schema histories to study schema evolution. So the amount of schema histories available is quite large. Now, it is important for all empirical papers of this kind to declare the scope. So we work at the logical level of relational schemata for free open source codes from GitHub. We are not covering proprietary schemata outside the free open source world. We are not working at the conceptual or the physical level, and we do not deal with non-relational schema. Now, for this particular paper, we needed to establish a common unit of time for schema and source code. For various reasons, the individual commit is not good enough, so we needed something better. So we worked with months. We grew by the individual commit changes per month. And the unit of change for schema is the number of change attributes, whereas the unit of schema, the unit of measurement for project is the number of change files. And we have followed, again, a principled approach to extract the number of changed files for each project. So for each month, we have the number of change attributes and the number of change files representing schema evolution and source code evolution. Now, once we have that, we need some way to be able to compare them at the same scale. So we need to normalize them. And the best way that one could probably think of is to work with the cumulative progress. So cumulative progress is monotone over time, and the basic idea is that at each time point you measure what part of the total change you have collected until this time point. So this can become easily a percentage between 0 and 1 if you divide this by the total amount of change. So this directly makes schema and source code progress comparable. And it is quite frequent also that instead of using individual months, because different projects have different durations, we work with the progress of time at the horizontal axis, which means you have a 0% until 100% here too. So if you had a completely constant rate of change, you would have a straight line of 45 degrees. As a chart here, we have something different. And in all charts, the schema is the blue dotted line, and the source is the green solid line. So we can actually depict and compare schema and source code progress over time and try to see how they evolve together. So research question number 1, do they evolve hand in hand? Already from the charts here, you can see that this is not always the case. How to measure that the change is done hand in hand? We take advantage of the properties of the fractional cumulative progress. So you have two sequences, and for every time point, if their cumulative progress differs by a certain absolute distance, and this distance is below a threshold, which is this band here, then we consider them being synchronous. So if you have a 10% band and you say that their absolute distance is 3%, then we consider that they are pretty much in sync for this particular time point. Now, if you want a single number for the entire project, what you do is you take the fraction of time points throughout the entire history where they are in sync. So we call this theta synchronicity, and it gives you the possibility of working with a single number per project. Here you can see that for the entire lifetime of the project, they go hand in hand. So this has 100% synchronicity for a band of theta equals 10%. You cannot have theta being a large number. It has to be something like 5%, 10%. We have worked with both. There are not significant differences. And we use 10% for the value of theta as the breadth of this band, practically. Now, the actual question was, how often are schemata and source code in sync? And basically, the histogram of the 10% synchronicities shows that you have all kinds of behavior. So the horizontal axis is what is the theta synchronicity, the 10% synchronicity of the individual projects, and the bar shows how many projects fall within this bucket of the histogram, and you see that you have all kinds of behavior. So there is no single law that characterizes the coevolution of schema and source code, although there is one observation that is depicted in the scatter plot in the lower part of the chart here. In the horizontal axis, you have the project duration. In the vertical axis, you have the value of 10% synchronicity. Each point is a project, and what we see is an absence of points at the upper right-hand side triangle, which means that as the projects age, they have more than 60 months, which is 5 years of age. You see that progressively you see less and less projects having schema and source code in sync. So as they age, they tend to evolve the schema less. Now, second research question is how premature does schema complete its evolution with respect to time or source code? Again, this is due to our previous results, where we have observed if there is a single law that governs the area of schema evolution, is its absence. We call this gravitation to rigidity, and it is the tendency to avoid change, especially as time passes. We believe that it is a fair question to ask that how probable is it that the project will have schema evolution preceding source code evolution, and for what percentage of its life? And we also ask the same question with respect to time. Now, if for a long period of time the progress of schema evolution is higher than the progress of source code evolution, this means that we fix the schema, we continued to develop the code. So for a long period of time, the cumulative number of percentage of change for the schema was above the cumulative percentage of change for the source code. And this is the case here, where the blue line is the schema. At 20% of the life, they had completed the schema evolution, whereas the project continued having some changes in the source code for a significant amount of time. Similar is with respect to time. So time here is the horizontal axis, and we see that at the 20% of time, you have 100% of evolution. So schema evolution is ahead of time also, not only just of source code, but ahead of time also. And if you want to see what happens with the entire data set of 195 schemata, what you can measure is the fraction. Take a project and measure the fraction of the number of months where schema was ahead of source code or schema was ahead of time, respectively, versus the entire lifetime of the project. Both are measured in months. So you have a fraction that is necessarily between 0 and 1. You see 41% of the projects had the schema being ahead of source evolution for at least 90% of the time. And here you see the percentage for each bucket of the histogram, and here you see the cumulative. Similarly, for time, 51% of the project had the schema evolution being ahead of time for at least 90% of the project's lifetime. And if you take this line in the middle, 71% of the projects had schema evolution being ahead of source code evolution for 71% of this project, and for at least half of the project's lifetime, and for 78% of the projects, at least half of the lifetime, schema was ahead of time. So overall, this quite clearly shows this build and freeze rigidity, because it is quite often that not only they're not hand in hand, but schema is significantly in ahead of time or source code. Now, another question is, how often does this happen? Always. There is a significant amount of cases where this happens. Always, for 100% of the months of the project's life, you have schema being in advance of source code or time. So 41% of the projects had the schema being in advance of time, always. And 29% of the projects had the schema being in advance of source code, always. And 28% both. Then we have to move on to research question number 3. When does this happen? When do schemata attain a significant amount of their evolution? So basically, we introduce the notion of alpha attainment. So we give we specify a threshold alpha, which says that the time point where the schema attains alpha% of its evolution is the alpha attainment time point. Here in the example, we say 75% as alpha. So at which time point did the schema attain 75% of its total evolution? At this time point. If the horizontal axis is individual months, then this is alpha attainment. If the horizontal axis is the fraction of time, then this is the fractional time point. So here the alpha is 75%, and 75% attainment took place at 14% of the project's lifetime. Of course, in a linear constant scenario, you should have alpha% of evolution at alpha% of time. Here, of course, we have way much earlier. Now, how do we measure this? We use different values of alpha, which you see at the horizontal axis of this chart. So we have alpha 50%, 75%, 80%, and 100%. And we measure for how many projects you attain 50% of schema evolution at 20% project life, which is the first bar in all quadruples, at the 50% of the project life, which is the second bar in all these 4 quadruples, and so on for 80% and 100%. And for example, this bar here with the 26 projects says that 26 projects out of 195 obtained their 50% attainment point in 80% of their project life. So they obtain it later than the linear progress. Whereas here you have 98 projects, practically half of the data set, obtaining 75% of the evolution in just 20%. The first bar is 20% of the project life. And as you can see, the first bars are impressive. They are way too much. And a very large number of projects that attract schema changes very early in their life. Right, 2/3 of the projects, for example, attain 80% of the schema in the first half of their life. So this is as clear a gravitation to rigidity as one can get. Because the first bars, 20% of the project life is very likely to attain a very high number of the schema change. To summarize the findings, when it comes to the question of whether source code and schema evolve hand in hand, there are all kinds of behaviors. Typically, we see that if a project lasts too long, the schema starts to stop being hand in hand with respect to source code evolution. With respect to how probable is it schema being in advance of source code and time, we see that the large majority of projects show schema being in advance of source code for a very large percentage of time. The same happens with time also, which means schema evolution happens early in the project's lifetime. And with respect to which time point, in fact, the significant amount of change has taken place, we see that typically gravitation to rigidity is widespread. The schemata obtain a large amount of their change very early enough. Of course, there is also exceptions to this rule. So we see that there is a significant amount of projects that do not obtain the change too early, but continue to evolve the schema until the end. Coming to an end, I would also like to mention that everything is online. You can go to our group's GitHub to see the schema evolution datasets, and you can go to our schema biographies page to see all the papers, and also links to the code and the datasets. And with this, I would like to thank you for watching.